Good afternoon, everyone. Thank you for joining today's webinar. We're going to get started in a few minutes, just after the top of the hour. So if you just hang on, we'll get started in a few minutes. Thanks for your patience. All right, let's get started. Hello, everyone. Welcome to today's webinar, Accelerate Software Delivery with Azure DevOps. My name is Dan Eggleston. I'll be presenting today's webinar. The main theme of today's webinar is to provide some information about the value of DevOps, the value to development organizations primarily, but it also talks a little bit about the value to business, and specifically how the latest release of Microsoft Azure DevOps enables you to realize that value. All right, so before I get started, let me tell you a little bit about myself. I'm the practice director at the Bravado Group. I've been delivering software solutions in the enterprise for over 20 years. Primarily it's been on the Microsoft platform, but I've served in many different roles as developer, technical lead, solution architect, and most recently as manager of software development organizations. DevOps in particular is a topic which I'm really passionate about. A development organization delivers value to the business with the release of quality software, and the principles of DevOps center around that process of delivering value to customers or end users faster without sacrificing quality. And these are really principles that have guided my development management philosophy for many years. So I'm excited that Microsoft continues to support developers in their pursuit of these principles, and then specifically with the release of Azure DevOps. The Bravado Group, we're an IT services firm based in Cleveland, Ohio. We have kind of four main service areas: UI, UX design. We do web, mobile, cloud application development. That's developing content management solutions using Sitefinity. That's one of our partners, Progress Sitefinity. We do kind of app modernization, and then of course we do a lot with DevOps on the Azure platform. We also do data management and integration. So web services, API management, data integration. We're able to leverage one of our other partnerships, Dell Boomi, which is a integration platform as a service provider. And then we do quite a bit with the cloud. So cloud services from cloud strategy, architecture, clearly migration, and cloud operations. We are a Microsoft Gold partner in both DevOps and application development. And obviously, I mentioned our real focus is web and mobile solutions hosted in Microsoft Azure. And then kind of another side of our business, we also do help companies with IT staffing needs. So in this webinar, we're going to get started just by level setting, answering the question, what is DevOps? And kind of look at its recent evolution. Next, we'll cover the need and business value of DevOps to an organization. We'll move on and talk about the common DevOps practices and principles, including continuous integration, continuous delivery, continuous deployment, infrastructure and configuration as code, and application monitoring. And then finally, we'll introduce you to Microsoft Azure DevOps and show you the best way to get started with DevOps within your organization and ways of getting started with Microsoft Azure DevOps in particular. Before I get started with today's content, let me go over just a few housekeeping items to talk a little bit about this LiveStorm webinar platform. So first, today's webinar will be available on demand directly after the live session, so you can rewatch it. You should receive an email with a link to that on-demand session right after it completes. Also, you can download the presentation that we used in the webinar. We'll have the presentation available on our website, www.depravadogroup.com. And there you'll also find blog posts and a schedule of other upcoming webinars and events that we hold either online or here in the local Cleveland market. And then lastly, we'd love to hear from you during today's presentation. If you have questions, feel free to use that questions tab on the right side of the presentation window. We'll be answering questions at the end of the session. If we don't get to your question today during our allotted time, we'll be sure to follow up with you afterwards. All right, so let's dive into the content. So what is DevOps? Well, before DevOps, you had the development team, often broken down further into development and quality assurance, and the operations team, each working within their own silos, each with their own priorities. The development team developed new code in an isolated environment, and that development environment typically was for quality assurance to perform their testing, and then if all the requirements were met and validated, they would release that code to the operations team to actually do deployment into production. The operations team then deployed it and then maintained it from that point forward. One of the problems with that approach is that it's usually a long time between software releases, and because the two teams were working separately, the development team was not always aware of operational roadblocks or just challenges that the operations team was having that might prevent the solution from working as anticipated. So the goal of DevOps is to change that, improve the relationship between development and operations by really advocating better communication and collaboration between the teams. And ultimately, the goal is to release software faster while maintaining really high quality. So that DevOps approach seeks to bring together application development and deployment into a more streamlined process that aligns development, quality assurance, and operations teams' efforts. The approach also shifts some of those operation teams' responsibilities back to the development team to facilitate continuous integration, automated testing, continuous delivery, and application monitoring processes, which we'll talk a little bit more about later in the presentation. So the necessity for tearing down the silos between development and operations has expedited the need to release code faster and more frequently to help organizations respond in a more agile manner to deliver value to end users more frequently and deal with kind of the ever-changing set of business requirements. This need is nothing new, but certainly the increasing use of cloud computing and advances in software-defined infrastructures, the use of microservices, containers, and really just this evolution in automation have made it easier than ever to realize this goal. So Microsoft came up with this quote. So they describe DevOps as the union of people, processes, and products to enable continuous delivery of value to end users. The DevOps culture is an extension of agile and lean principles with an added focus on service and quality. So by designing, building, testing, deploying, managing, and operating applications and systems faster and more reliably, DevOps practitioners seek to create value for customers and a competitive advantage to the business. So in the DevOps lifecycle, you start kind of at the top up here with observations of the business, of the general market, certainly needs of your users, your current user behavior, and available telemetry data, so how they're using software not today, to create a backlog of work items. Right? Then you enumerate the options of what you can deliver, right? Go through a planning process, perhaps doing some experimentation, ultimately to develop what you're going to build. So you decide what to pursue, and you act by delivering working software to real users. So go through this develop and test cycle. And then finally, when you release it, you want to understand how your users are using it. So you monitor the usage of the software in production and use the learnings to inform the next cycle. So all this happens in some cycle time. Now, through our experience and working with many customers, we find that roughly 1/3 of the deployments will have a negative business result. Roughly 1/3 will have a positive business result, and 1/3 will make no difference to the end users. And ideally, you want to, fail fast in those deployments that don't advance the business, and double down on those that do support the business. So when you adopt DevOps practices, the objective is to shorten this cycle time by working in smaller batches, using more automation, kind of hardening and really refining your release pipeline, and improving the telemetry or the ability to monitor what your users are doing to deploy more frequently and ultimately find those deployments that are going to provide the most value to your customer base. So the more frequently you deploy, the more you can experiment, the more opportunity you have to gain validated learnings through each of these cycles. And this acceleration in validated learning is really the value of the improvement. So why DevOps? So really the consequences of being of the inefficiency of kind of the old way we do this are real, right? And so in the real world, there are consequences if you're unable to deliver high quality software quickly, or you build the wrong thing from the beginning. So I'm going to call out a few stats from this slide. There's many on here, but 40% of IT implementations end up getting reworked because they don't meet the user's original requirements. The average cost of 1 hour of downtime of a customer-facing app is upwards of $100,000 per hour. This does not consider the damage to reputation, which can be even greater. Fixing production issues takes on average 200 minutes per incident. And while 3/4 of development teams have adopted agile methodologies today, enabling them to develop faster. And while this is great, it doesn't help if the development team is agile, but deployment still takes weeks or months because IT operations doesn't execute in that same agile way. So these are just a few high-level examples, but today all the data we have points to really the same conclusion, and that is more than just frustration or minor delays. Really, this lack of collaboration between development and operations can have really a substantial impact on a company's bottom line and ultimately their success. But when DevOps is done really well, it can have significant benefits to a development organization. So with the implementation of DevOps practices, organizations are really balancing two important performance indicators. And it's kind of broken up in this slide between the top half of the circle and the bottom half of the circle. So let me start with the top half on agility, right? Agility is, kind of as defined by a company or a development team's ability to increase the deployment frequency and reduce the change, that the lead time it takes to implement a change. This allows you to react to dynamic business conditions and changing requirements. So we want to try to increase agility, but we also want to maintain reliability. So kind of the bottom half of this slide talks about reliability as defined by an organization's ability to reduce change failure rates. So when we do implement a change, reduce the likelihood of failure, and reduce the time it takes to detect and repair those issues. So in research that was done, I think it was last year by DevOps Research and Assessment, high-performing companies have 46 times more frequent code deployments and 2,555 times faster lead time from code commit to deployment, really talking about how agile they are. And then as well, they have 7 times lower change failure rates and 2,604 times faster time to recovery from incidents. And this is as compared to low performing companies. So they have increased agility while maintaining very high stability and reliability. So I talked about two, agility and reliability, or quality, of these 5 main value propositions, but just want to talk, just lay out kind of all the benefits of DevOps. So we do have increased agility and increased quality or reliability, but what we're also trying to generate is improved collaboration, accelerated innovation, and ultimately as well reduced failures. So agility and increased quality are 2 of the main drivers. But reduced failures and accelerated innovation cycles are another set of key benefits clients might want to consider when thinking about implementing DevOps into their organization. To a large extent, most of these drivers can directly be related and translated into cost savings. Reducing failures will have an impact on cost avoidance. Increased quality will have an impact on end user satisfaction. And therefore, companies may be able to increase their sales or otherwise reduce support expenses. So talking then about DevOps practices, some of the things that organizations would want to put into practice as they're implementing DevOps. So as I said earlier, DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity, evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. But there are several key practices listed here that really help organizations innovate faster through automating and streamlining the software development and infrastructure management processes. I'm not going to go over all of these. I'd encourage you to go after this presentation and really dig into these. But let me cover kind of some of the really significant practices that are kind of fundamental to good DevOps implementation. So first is continuous integration. So many people in development organizations will have a really good understanding of continuous integration, but really continuous integration is a software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are executed. So the key goal for continuous integration is to find and address bugs quicker, improve software quality, reduce the time it takes to validate and release new software updates. Other benefits include less wasted time on fighting merge issues and really getting rapid feedback to the development team about the changes that they're making and merging into the code repository. Infrastructure as code. This is a practice in which infrastructure is provisioned and managed using code and software development techniques, very similar to what the development teams have been doing for years, but using techniques like version control and continuous integration when managing the infrastructure. And really, the cloud's API-driven model enables developers and system administrators to deploy, configure, and interact with infrastructure programmatically and at significant scale. So instead of needing to set up and configure resources manually, they're able to use this API-driven model to do it programmatically. In doing so, the engineers can interface with infrastructure using code-based tools and treat infrastructure like how they treat application code, because the definition of infrastructure in the servers is in code and can quickly be deployed using standard patterns. This can be done in a very repeatable way and at large scale. Automated testing, this is something that's been used by many development organizations and quality assurance organizations, but really is a key to DevOps. The key to building quality into software is making sure that we can get fast feedback on the impact of changes. Traditionally, manual inspection of code changes and manual testing was used extensively. where testers would follow documentation describing the steps that were required to test various functions of the system, and they're doing that to demonstrate the correctnness of the system. This type of testing was normally done in a phase after a development complete milestone. But the strategy has some very significant drawbacks. One, manual testing takes a long time and is relatively expensive to perform. So it creates a bottleneck that prevents us from more frequently and getting feedback to developers. Sometimes it could be weeks or months after they actually wrote the code to be tested. Manual tests and inspections are just not very reliable. People are kind of notoriously bad at performing repetitive tasks, such as regression testing. And it's really extremely hard to predict the impact of a set of changes on a complex system through inspection. And then, this is the age-old problem that when systems evolve, as in the case of modern software products and services, we end up spending a considerable amount of time just updating the test documentation to keep it up to date. And so the time that we're spending on updating test documentation is taken away from the overall time we're spending actually validating the solution. So to build quality into software, we need to adopt a different approach. Our goal is to run many different types of tests, both manual and automated, continually throughout the delivery process, and really to automate as much as possible. This includes really every type of testing, from developer unit testing to performance, load, and security testing. We want to automate as much of that as possible. All right, continuous delivery. So continuous delivery is a software development practice where code changes are automatically built, tested, and prepared for release to production. So this expands and kind of takes continuous integration a step or two further by not only building and validating the code, but deploying those code changes to a test environment or even a production environment after the build stage, so after that code has been built and validated. So when continuous delivery is implemented properly, developers will always have a production-ready build artifact that is passed through a standard test process. The emphasis on automated builds and automated testing for quality assurance capitalizes on the efficiency of successful test automation and really is essential to this goal of being deployment ready, kind of production deployment ready. So continuous delivery kind of takes it to that point of production deployment ready. There's a concept of continuous deployment, which really takes that this continuous delivery process even one step further, and not just make an artifact of a production-ready deployment, but this is actually implementing a process by which your deployment is to all the way to production, so that you're deploying a successful and validated build all the way to production in a fully automated way. So kind of diving into continuous delivery a little bit further, there's kind of 5 main principles at the heart of continuous delivery. So one being building quality in from the beginning. So it's much cheaper to fix problems and defects if we find them immediately, ideally before they've ever been checked into version control. And this is typically by running automated unit tests locally on the developer workstation. But you might have heard of this term, shifting left. So shifting left is this idea of finding and preventing defects as early in the software delivery process as possible. So if we look at kind of a spectrum of, on the left side, the developer actually doing their development work and validating what they're developing, and all the way on the right of this kind of timeline of the deployment to production and ultimately the release of that software to the end users. What we want to do is find the issues as early in that timeline as possible. So the idea is moving quality, or the idea of validating the quality, moving those tasks to the left as early in this time spectrum as possible. Finding defects downstream to the right through inspections, such as manual testing, is very time consuming. And so as we shift these items to the left, it's just making it that much easier, cheaper, and ultimately, you're going to, the validation or the quality of the code is going to be improved. Continuous delivery principle. And the second one is just working in small batches. In a traditional phased approach to software development, handoffs from dev to test and then test to IT operations consist of whole releases, could be months worth of work by teams consisting of tens or even hundreds of people. In continuous delivery, we take the opposite approach and try to get every change in version control as far towards release as we can, getting feedback as rapidly as possible. So working in small batches has many benefits. It reduces the time it takes to get feedback on our work, makes it easier to triage and remediate problems, and ultimately increases the efficiency and general motivation of the development team. All right, another one of the principles is that we want computers to perform the repetitive tasks and let people solve the problems. The goal here is really for computers to perform the simple repetitive tasks, such as regression testing, so that humans can focus on problem solving. Really, in this case, computers are doing what they do best, people are doing what they do best, and they complement each other really well. And then, relentlessly pursue continuous improvement. The best organizations are those where everybody treats improvement work as an essential part of their daily job, and really nobody is satisfied with the status quo. And ultimately, it's when everyone takes responsibility for that quality, and ultimately the successful release where things start to go really, really well. Then, kind of one of the last DevOps practices I wanted to touch on is application monitoring. So with application monitoring, organizations monitor metrics and logs to see how application and infrastructure performance impacts the experience of their end users. So by capturing, categorizing, and then analyzing data and logs generated by applications and infrastructure, organizations understand how changes or updates impact users. This sheds insights into the root causes of problems or unexpected changes. Active monitoring becomes increasingly important as services must be available 24/7, and as application and infrastructure update frequencies increase. So creating alerts and performing real-time analysis of this data also helps organizations more proactively monitor the services or the solutions they're offering. Operations teams have really long monitored errors and established alerting frameworks when system resources are reduced or application performance hits certain thresholds. But application monitoring also adds measuring application health, customer usage, usability, doing change analysis, and helping organizations form a hypothesis and quickly validate or disprove different strategies. So that leads us to Azure DevOps. Late last year, Microsoft released Azure DevOps as an additional set of tools for development and operations organizations to implement the DevOps practices I just mentioned. This is an evolution. It's a newly branded product, but it's really an evolution of a couple previous products. One, Team Foundation Server, and then more recently, Visual Studio Team Services. But even though this is just an evolution, really it is a really important step for Microsoft in their continued support of DevOps practices and providing tools to support developers and operations organizations around the world. So Azure DevOps is an end-to-end solution for organizations looking for an enterprise-grade tool chain for their DevOps implementation. Azure DevOps provides tools for each phase of DevOps, the planning, creating, verification, packaging, releasing, configuring, monitoring of a solution. Azure DevOps has a component to support all of that. So Azure DevOps, the product consists of 5 main components: Azure Boards, Azure Pipelines, Azure Repos, Azure Test Plans, and Azure Artifacts. And we're going to go into each of those here in a bit. But with these tools provided by Microsoft Azure DevOps, as well as the tried and tested industry principles that we mentioned earlier, right? The adoption of DevOps can dramatically improve the operations and output of a development department while driving down operational costs. So let's dive into each one of these and and do a little overview of the different components of Microsoft Azure DevOps. So let's start with Azure Boards. So Azure Boards allows you to plan, track, discuss work across your teams. Right? With Azure Boards, you can kind of quickly and easily start tracking tasks, features, bugs associated with your project. And you do this by adding one of 3 work item types. The work item is kind of the fundamental unit of Azure Boards. The work items are, kind of out of the box, are called epics, issues, and tasks. This is kind of part of the basic process template. But those are work items are highly configurable, and you can actually create work item types, custom work item types, to kind of support your development process that you use within your organization. So really, work item types, work items are that fundamental piece of work that you're tracking within Azure Boards. So through the built-in integration with version control tools, code changes can be directly linked to work items. That's the telling a developer, here's the work you need to do. But also provides a traceability through the whole DevOps cycle that a work item was turned. There's a piece of code that was checked in against a work item. Ultimately, that piece of code was checked in, built, and deployed to address a specific issue with the system that was documented in that work item. Now, boards, the idea of boards is to present work items as cards. You kind of see it in that a screenshot on this page. So this supports kind of quick status updates through drag and drop. You'll see between new, active, staging, and deployed on this screenshot. Just by dragging and dropping each of these cards, I can change their status. Features, it's kind of like a sticky notes on a physical whiteboard. So this is very commonly used in the Kanban or Kanban practices, and kind of helps development organizations visualize the flow of work for a team. All that is simulated and implemented within Azure Boards. Azure Boards also provides a presentation of work items as a list, and this is called a backlog. So product backlog represents your project plan and a repository of all the information you need to track and share with your team. So portfolio backlogs allow you to group and organize your backlog into a hierarchy, and then use it to plan, prioritize, and organize the work to be done. And usually, kind of based on Scrum methodology, you would organize the backlog, the work in your backlog, into sprints. So sprints, this is where you're kind of assigning work to a specific iteration, path, or a period of time. So that's the name sprint is given to that small window of time used to deliver a piece of functionality. So from your backlog, you can assign work to an iteration path just using drag and drop. You can then view the work in separate sprint backlogs. And ultimately, we're using this to implement the Scrum practices that are becoming more and more frequent within development organizations. So, Azure DevOps provides a rich querying capability to create filtered lists of work items based on different criteria that you define, all through a really robust query editor. All right, Azure Repos. So Azure Repos is a set of version control tools that you can use to manage your code. Whether your software project is large or small, using version control as soon as possible within your development cycle is a really good idea. It's a best practice. Version control systems are often, they're software that help you track the changes you make in your code over time. And as you edit your code, you're telling the version control system to take a snapshot of your files periodically. The version control system saves those snapshots permanently, so you can recall it later. So you have a kind of complete view of your code at any given point in time. You use version control to save your work and coordinate code changes across all your team. So allow your development team to to work together on a single set of features for your solution. Azure Repos kind of supports two different types of version control. One is a distributed version control system that's based on Git. Git is the most commonly used version control system today and is quickly becoming really the standard for version control. Git is, as I said, a distributed version control system, meaning that your local copy of the code is a complete version of the version control repository that's held on the server. But Azure Repos also supports kind of what now is becoming more of a legacy version control system, and that's called Team Foundation Version Control. This is the system that was built into Team Foundation Server, and more frequently, or more recently with Visual Studio Team Services. This is a centralized version control system, but more and more people are moving to Git, and Azure Repos can support both. So if you do have existing repositories in Team Foundation version control, that's supported. But certainly moving to Git is probably the preferred method, and certainly what most development organizations are starting to implement. All right, then we have Azure Test Plans. So quality is a vital aspect of software systems, as I mentioned earlier, and manual testing and exploratory testing continue to be an important technique. As much as we're trying to automate, there's always going to be a place for manual testing and exploratory testing. So, in today's software development processes, everybody in the team owns quality, including developers, managers, product owners, user experience advocates, and Azure DevOps provides a rich and powerful tool set that everyone on the team can use to drive quality and collaborate through the development process. So the easy-to-use browser-based test management solution that's part of Azure Test Plans really provides all the capabilities required for planned manual testing, user acceptance testing, exploratory testing, and gathering feedback from stakeholders. Now, with Azure Artifacts, many software projects today, and more so, rely on package managers. So if you're in the development world, this would be a NuGet or NPM, and you kind of depend on those packages to successfully build, a new solution. So it's also possible that other software projects you have that you're working on, they rely on packages being output from other build or release processes within your organization. So these would be shared components. Maybe you have a architecture team that's building a lot of the base framework components that your solution is going to depend on. So Azure Artifacts provides just a great set of features for effectively managing all of those packages, both the public available or open source packages, as well as those being developed and shared within your organization. So first, Azure Artifacts provides privately hosted packages. This is for, it provides a consistent access to components needed by your build. So it's a common and consistent single source for retrieving those packages. It supports enterprise authentication to manage permissions on who is allowed to access those components. Seamlessly integrated with the build and release management tools of Azure DevOps. And it also provides a discoverable and a way of searching for packages across your enterprise. And so all of the shared artifacts that you're building within your organization become available to throughout the enterprise. And then really finally, where I think the real power of Azure DevOps lies is with Azure Pipelines. So Azure Pipelines is a fully featured continuous integration and continuous delivery service. It works with your preferred Git provider. That could be Azure Repos, but it also could be an external Git provider, and can deploy to major cloud services, which could include Azure, but also could include Google and Amazon. So if we start with your code on GitHub or GitLab, Bitbucket, or as I said, Azure repos, then you can automatically build, test, deploy your code to Microsoft Azure, Google Cloud, or Amazon Web Services. So use Azure pipelines to configure and automate your build and delivery tools and environments using YAML. So YAML is the format of defining your Azure pipeline steps and dependencies. Alternatively, you can use the visual designer within Azure DevOps web portal to actually graphically and visually build your Azure pipeline. So Azure Pipelines really combines continuous integration and continuous delivery to constantly and consistently test and build your code and really ship it to any target. You can start with really almost any language. So whether it's Python, Java, PHP, Ruby, C#, Go, as I mentioned, it integrates with version control systems, GitHub, Azure repos, Bitbucket, Subversion. You can build all kinds of different application types. So Java, JavaScript, Python, .NET, PHP, C++. And as I mentioned earlier, multitude of deployment targets, whether or not it's a cloud service like AWS or Google or Microsoft Azure, but it could also be containers, virtual machines, Azure Platform as a Service, and really any on-premise or cloud target. And it can do that in many different package formats. So you can publish NuGet, NPM, or Maven packages to the built-in package management repository. You can also use any other package management repository as a target or a storage mechanism for your packages. So Azure DevOps is an end-to-end solution for organizations looking for an enterprise-grade toolchain. However, if you're looking to leverage existing investments or preferred tools, any of these components can be disabled and replaced with third-party solutions. So Azure DevOps works with DevOps tools that you might already have implemented in your organization. This can be through native integrations or with extensions available in the Visual Studio Marketplace. Azure DevOps lets teams choose the tools that are right for them. You can mix and match to create workflows with tools from Microsoft, open source, or your favorite third-party tools. And as I said, target any cloud, on-prem environment, or deployed environments that and hosted environments, kind of whatever your needs are. And this is just a list of all the different a lot of the different vendors that play in this space. So, whether you're using Jira for tracking progress, or GitHub or Bitbucket for source code, using Gradle or Jenkins for build, Octopus Deploy for deployment, Terraform or Chef for environment management, Azure DevOps really can support this entire ecosystem. Now, the journey to successful DevOps isn't linear, although this graphic does depict it in a linear way. Organizations will have its own distinct path to success based on their starting point, capabilities, and organizational goals. That said, most teams evolve DevOps over time. They do so in a very predictable way. Just as an example, building an application happens more frequently than any other action. So therefore, it's kind of logical to automate that first. And kind of the typical order in which things are automated is you're first going to automate your application build, then your application deployments, then your environment configuration, and then kind of ultimately the environment provisioning. So let's take a quick look at these maturation steps. So the most basic level, level one, is where most of what you're doing is manual. So at this level, a team might develop an application, need to deploy it to a new environment. A server administrator manually provisions the servers needed for the new environment. Once that's completed, he'll configure those servers. A developer will build the application, possibly package it up or do kind of an Xcopy deploy approach, maybe even deploy it directly from Visual Studio. The developer will then deploy the application, including the databases, services, and whatever else is needed. And once all that is done, one or more people will verify the application has been deployed correctly. And if you're going to do this one time, yeah, there's really nothing wrong with that approach. However, when was the last time that you ever had to develop a single solution in a single environment? And so that's really when then you transition to kind of level 2 of the DevOps maturity model of automating the build. So to really kind of fully realize level 2 maturity, the automated build system should have a few characteristics. So one, should run on a non-developer machine, preferably a server, so that we're doing the build in a kind of isolated environment. It should build on a trigger, so that could be either a check-in or on a schedule. It should execute unit tests, and it should notify the team if there's a failed build. You'd have the ability to block check-ins under certain conditions, so put in those kind of validation gates to make sure that development patterns and practices are being followed, coding standards are being followed, and then ultimately, coming out of the build system, it should package the application to simplify the deployment process. Leveraging the above ensures that if source code is checked in that doesn't compile, the team is notified as soon as possible for remediation. It also ensures that even if the code does compile, the team is notified if the updated source code causes a unit test to fail. So when automated builds are configured to run on a trigger or a frequent schedule, it is often referred to as continuous integration or continuous build. And that's kind of where we are with this level 2. And as you mature even further into automated deployment, and this is where we're really starting to get into the meat of the value of DevOps, this is where we're really trying to eliminate manual deploys since they are rife with human error. So files can be copied to the wrong directory, or even worse, the directory in the wrong environment. Database scripts might not be executed in the correct order. Services may be shut down for deployments and then not restarted. So there's a lot of value to going through this automation process. So automating deployments is usually the next area where DevOps will mature, or a team will mature. And the value of taking this step to automate the deployment is that all steps are performed in the correct order every time. There's a lot of consistency there. There's a lot of time saved. So you might ultimately invest time in automating the deployment, but the long-term time savings is significant. And then really once configured, there's no special knowledge of the system needed in order to perform the deployment, right? You just, based on the triggers of a code check-in, the code is deployed and deployed into the test and test environment. So not only are manual deployments fraught with human error, but they're also very time-consuming. That all kind of goes away with as you start to get into automated deployments. And then in the level 4 level of maturity is continuous delivery. And this is the level of maturity that really introduces a lot of what we talked about earlier in the DevOps patterns and practices. This is where we're getting into that idea of immutable continuous delivery. So means I can blow away any environment at any time, and the automated deployments will use containers or infrastructure as code or some combination to ensure the proper provisioning and configuration of the environment ahead of actually deploying the solution into that environment. Depending on the needs of the project, many teams won't get to level 4 maturity. There may not be a huge need for it, but if you have a large number of environments and that automating the build up and tear down the environments becomes really appealing, this is the maturity level that you really want to should be a goal to achieve. And then kind of the last final level in automation or in the DevOps maturity model is fully optimized. So the final level is really further increasing the deployment capabilities of your immutable environments. Kind of the line between level 4 and level 5 can be blurred at times, but level 5 generally refers to teams doing hundreds or even thousands of deployments to production per day. There are very few companies that will achieve this level of automation, or really, in fact, there's this level of automation is not necessary for most. These features, require a considerable amount of investment and effort to set up and implement, and only applications that require kind of hyper deployment to production, or this idea of very frequent deployments to production, hundreds of times a day, is where this level 5 fully optimized maturity is appropriate. So this is often kind of very large commercial customer-facing applications. All right, so how do you get started with DevOps? So based on my experience, this is what I would recommend. Number one, remember that you will take your own path to implement DevOps, and every organization is going to be slightly different. There's a lot that goes into implementing DevOps, and you, as an organization, really need to determine the best path to take for your organization. And kind of where you start with that is, first assess your organization's maturity level. When it comes to DevOps, you need to know where you are starting to determine your path forward. Then, involve the team to define a real holistic approach for your organization. Right? Successful DevOps, it's a collaboration between business, developers, testers, IT operations working together around these shared objectives. And you really need to listen to their input about how to start the process, and even throughout the implementation of the process. But what that means is you really need, if you don't have it, you need to create a collaborative culture. Make sure your organization is free of those silos. Right? Not all organizations can eliminate the silos entirely, but by involving and aligning stakeholders in the development process of the implementation process across departments, you can reduce the impact of organizational silos, and this will help to establish a good collaboration between the different teams in the organization and further drive that that cultural change throughout the whole organization. One thing that I would highlight too in how best to get started is, don't think that you can just buy DevOps, right? So we just talked about Microsoft Azure DevOps as a tool, but it's not just a set of tools that will enable you to implement DevOps, right? Just don't fall into that trap, right? Products are critical to implementing and connecting teams across silos and enabling the automation that supports DevOps. But tools alone will not solve your problem. You really need to do all the hard work, creating the culture and looping in all the important aspects of continuous integration, continuous delivery to ensure that the tools are doing their jobs. I'd say start small, right? Before you try to achieve DevOps across your organization, you need to make sure it works on a micro scale, ensuring there's kind of a bottom-up adoption and a top-down buy-in from key managers and technical leadership. Management buy-in can be difficult and time-consuming at the start of the implementation, but it's required, and really something I would highly encourage you to ensure you have. Because generally the implementation of DevOps will affect timelines and budgets, and the way a team works in the near term. So you really need management to buy in to be able to work through that. And then make sure you're successfully measuring your progress. An effective DevOps culture includes a commitment to measure results and report on quantifiable metrics. So, to stand up your delivery pipeline, you need to build in the ability to do to measure these things, continually track the progress towards achieving your goals. And then specifically with Microsoft Azure DevOps, first, it's 100% free to get started in using the tool. And so I'd highly encourage you to go out there and create a user if you don't already have one, and start playing around with Azure DevOps. There is a huge amount of documentation out that Microsoft makes available, and along with the documentation are a slew of tutorials to help you get started. All of that can be found at azure.com/DevOps, and I encourage you to go out there for all the information on how best to get started. Good. Well, I do want to thank you. That's the content for today's webinar. Thank you for joining today, and I hope you found the information very informative and valuable. If you have any questions, I'm happy to answer them. But also, don't forget, you can follow us on social media. I have all the social media links here on this slide. If you have any other questions that you aren't able to ask in today's webinar, feel free to reach out to us. Go to theprovidogroup.com or email us at info@theprovidogroup.com, and we're happy to respond to any and all questions or inquiries as they come in. So thanks again for your time. Have a great day.